This is a Sutotal production. Alright, Chem Minions, this is going to act as our third and final practice video for Chapter 1. Here, this is kind of a recap from what you should have learned back in, say, Chem 1 or in Survey of Chem 1. But with this, calculating formal charge. And so one of the things that all of these atoms that we're going to calculate the formal charge for, we are looking at them in the realm of, I've shown you everything, right? So I've shown you all of the lone pairs. I've shown you all the bonds that are attached to it. And so from there, you should be able to calculate the formal charge. Now, this will require that we're going to use our periodic table. So here's kind of an example of the periodic table that I would give to you on your exam. So for this periodic table, we're looking at, mostly, we're going to be looking at carbon, nitrogen, and oxygen. Okay, so in these first few, it looks like these top three are oxygen, these middle four are nitrogen, and these bottom three are carbon. So the reason that we need the periodic table, since we're talking about oxygen, in order to calculate the formal charge, we have to understand how the electron count for their valence shell is different in the structure based off what it started with in the periodic table. So oxygen, based off the periodic table, started with 1, 2, 3, 4, 5, 6. Right? So oxygen started with 6 valence electrons. All right. So at this point, we have to figure out, well, how many does it have now? And we can use that to calculate the formal charge. All right. So when we look at the oxygen here, you count every lone pair electron as 1, and then you count every bond. Even though a bond has 2 electrons in it, you count every bond as 1 electron. So now oxygen has 1, 2, 3, 4, 5, 6, 7, right? So it had 7. So it started at 6, right? And now we have to subtract 7 electrons from it. So, now we have to subtract 7. Sorry, not 7 electrons, but we have to subtract 7. And that gives us -1, right? Does this -1 make sense? Well, think about it. Oxygen on the periodic table has a formal charge of 0. It's neutral. Right now that it has 7, right, it got 1 additional electron. Each electron has a -1 charge. So 6 minus 7 giving me -1 is a perfect formal charge for this oxygen. So I'm going to put -1 right there. So that has a -1 formal charge. Now remember, oxygen started with 6. Now how many does it have? Remember, 1 per bond, so 1, 2, and then count each lone pair electron. So it's 1, 2, 3, 4, 5, 6. So it would have been 6 minus 6 or 0. So here, this bonding situation for oxygen has a 0 formal charge. Now we look at this oxygen. It has a double bond, but count each bond once, right? So we would say it's 1, 2, 3, 4, 5. So it went from 6. Now we're going to subtract 5, and that gives me +1, right? And that makes perfect sense, right? It has 1 less electron, so it lost a -1 charge. So it went from 0, -1, 0, and then it took away a -1 charge, so it became +1. All right? So that would be our formal charges. -1 for this one, 0 for that one, +1 for that one. And let me circle them so they're easier to distinguish from the math. All right. Next up, on nitrogen. All 4 of these are with nitrogen. So let's go back to our periodic table real quick. Nitrogen started with how many valence electrons? 1, 2, 3, 4, 5. Right? So it started with 5. I'm going to put that over here on the side. All right. So what I'm going to do is I'm going to say 5 minus the electron count. That's what I'm going to do. That's what I did all up here. All right. So remember, lone pairs count each electron as 1. Not the pair. Count each electron in the pair as 1. All right, and then count each bond as 1. So for this guy, it's got 1, 2, 3, 4 bonds. So we would have to say 5 minus 4, and then that would give us a +1. So here, this nitrogen has a +1 formal charge. We look at this nitrogen. It's got it's got a triple bond, but remember, count each bond once. So it's 1, 2, 3, 4, 5. So it would have been 5 minus 5, which is 0. So we don't see any change in the formal charge based off the periodic table. All right, next up, what do we have here? Nitrogen. We've got 3 single bonds and a lone pair. So it's 1, 2, 3, 4, 5. So this would also be 5 minus 5, or 0. All right, and then next up we have nitrogen with 2 single bonds and 2 lone pairs. So we would count this as 1, 2, 3, 4, 5, 6. So we would say 5. We would say 5 minus 6, right? And that would give me -1. So here this nitrogen has a -1 formal charge. All right, and looking at our carbon. All right, so before we do that, let's go over here to our periodic table. Carbon, it started with 1, 2, 3, 4 valence electrons. So we're going to say 4 valence electrons. That's kind of my note to remember. And so now we're going to count up the electrons that are around it. So this carbon has 1, 2, 3 bonds. So that's 3. And then a lone pair. So it's 1, 2, 3, 4, 5. So we would say 4 minus 5, which would give me a -1. So this carbon has a -1 formal charge. Here, remember, the carbon has every electron shown that's around it. So the only electrons in this are the 3 bonds. So it's got 1, 2, 3. So for this one, we would say 4 minus 3, or +1. So here, this carbon has a +1 formal charge. Okay, and that's actually quite common later on in this semester, where you would be seeing carbocations. That's a very special type of cation that we talk about in reactions. All right, next up we have this carbon here. So it's got, let's count the bonding around it. It's got 1, 2, 3, 4. So we would say 4 minus 4, or 0. So that has a 0 formal charge. All right, now this is not exhaustive, but I was trying to at least give you a situation, a positive, a negative, and a neutral situation for oxygen, nitrogen, and carbon. But there are, of course, other situations that we could see. But in the meantime, I just thought that this would be good practice for you to figure out how to count it up. All right, y'all stay weird.